You ready, Eddie? All right, we're going to play this game. All right, let's just talk about this here, okay? Do you guys recall when we had frequency distributions? We had frequency distributions. And then once we had those distributions, we drew pictures of things called histograms. Okay? Histograms. And we talked about it way back when. We said sometimes you have histograms that look like this. Okay? And we talked about this. And then I drew this picture, and then I asked you guys, what does that look like? And we said, this is a what? A bow-shaped curve. Well, yeah, it's a bow-shaped curve. But what it simulates is a distribution known as the normal probability distribution. Okay? And what's special about this distribution is there's a lot of phenomena. A lot of phenomena behaves this way. Okay? Things that grow naturally, normal distribution, things that are natural, like things like growth. You guys know that your height is something that's supposed to occur naturally. Even though we have different heights, there's differences in us, but we're supposed to grow naturally, right? There's nothing, we're not taking these hormones to modify our growth. What about weight? Same thing. We're supposed to, have certain weight associated with us. Okay? So these are sort of some of the basic ideas behind the normal distribution. Things like height and weight. You also have like IQ scores. You guys know even our intelligence is supposed to all be something that develops naturally. Now, what's happening is this. For these sort of situations, we have people, and we like to think of people as sort of being the same. But they're not the same. There are some people who are taller and some who are what? Smaller. But most people are in the center. They're in the average. Is that right? Even in terms of weight, there's an average weight, and some people weigh more, some people weigh what? Less. Even in the IQ scores, there's a typical IQ score. Most people are around that score. Some people measure higher. Some people measure what? Lower. Okay? So things that happen naturally usually have this type of distribution. It's called the normal probability distribution, the center of which is the average, the mean. And by this histogram, you notice that most people, this has the highest frequency value. Most people are around the what? Around that center. They're around the mean. Okay? You guys okay with that? Anybody have any questions so far? You know the water in your water bottles? Okay? You purchase volume of water. Do you guys know that even if you were to get another bottle, the same size, the same item, it's not going to have the exact same volume. It's going to be slightly off. It's going to follow this type of distribution where most of those water bottles in terms of volume of water are around this mean. Some are going to have more, much more. Some are going to have much less. Okay? But it's going to follow this normal distribution. Even components, right? Well, maybe we shouldn't use that analogy. Eddie will understand that analogy. You know, Eddie, for instance, like a resistor? Yeah. Exactly. You know that resistors, if you buy an 8 ohm resistor and you measure it, it's not even exactly 8 ohms. Well, what's happening is this. Depending on the process, depending upon the process, they may have a more accurate version of that resistor of 8 ohms, or even capacitor, doesn't matter, because the process that they use is much more accurate. It still may not be exactly 8 ohms. It'll be around the average of 8, but some will be really, and some will be less. So what happens is the more expensive the component is, the more it's closer to that mean value, more consistency you have. Okay? And that's no different than even thinking of people in terms of their height, their weight, their IQ score. A water bottle, it's no different. Okay? Because we value consistency. Okay? You guys okay with that? All right, let's see. So we'll note here that we have a certain center and a certain consistency associated with this normal distribution, with the averages and how consistent it is. Okay? And every physical phenomena that behaves naturally, height, weight, IQ scores, even processes, have a certain mean and a certain consistency value. Okay? Now, technically here, x is a random variable that is known as continuous, meaning it could be any real value, not the discrete values we've been talking about, like x is 0, or x is 1, or x is 2. Now the value of x can be 1.3976, or the square root of pi, meaning the value of x can be any real number. Like the volume here for this water bottle, even though it says 25 fluid ounces, it's not exactly 25 fluid ounces. It's probably more than 25, because if they do not put more, then they're actually breaking the law. It's called false advertisement. So it's probably something like 25.8697322419. And however accurate you want to be, you can be that accurate, but it's more than 25 fluid ounces. Okay? So when we say that this is a continuous random variable, what we mean is that the values can be any real number. Real number being on the real number line. Remember that real number line from algebra? Remember that? The values can be any real number. Not discrete values like counting arrivals, 0 arrivals, 1 or 2. Okay, that's what we mean by real value. Okay, fine. So before we start to really go through some applications of this distribution, we have to play what I call the, guess the percentage of the bell, that shaded game. So first, before we start that game, I'm going to ask you this question here. This is a bell, okay? And although my drawings are never really that great, the center of this bell is their mean, mu. And what do you guys notice about this bell? It's supposed to be symmetric. You may say, what does symmetric mean? It's supposed to be symmetric. And you say, symmetric about what? What is symmetry? Do you guys know what symmetry is? Anybody know what symmetry is? You guys know what a definition of beauty? Some people feel this is the definition of beauty. It's a face that is what? Symmetric. Do you guys know our faces aren't as symmetric as we think they are? What do I mean by that? If you draw a line, you got the left side of your face, and you have the what? The right side, right? Look in the mirror. Is your left side look symmetric to your right side? Do you? Do you know that you are considered in some regions ugly? If, I know it's sad, if the symmetry is really off. What do we mean by that? That the left and right side are very different. In art, you always want to try to draw a symmetric picture. But you know, most of us, or not most, all of us, our face isn't really symmetric. Do you guys know that? Look in the mirror. Put the line and go, oh my God, my left side, my right side. If it's very different, I hate to break the bad news to you. In other words, if you look like this, there is a problem. There is a problem. Okay? In some cultures, that's really bad. Okay? You guys know that? They actually measure, you can measure it anyway. I have a student who was a princess at Disneyland. I think she was Belle or something. You know what they did? They measured her face. They go through the measurements, everything, just to make sure she had the right proportions. Do you guys know that? You can't walk in and say, I want to be Belle. They're going to measure your face and see the proportions to see whether or not you are qualified. Okay? So if you look like that, that could be a problem. Okay? It could be a problem. So this Belle is supposed to be beautiful. It's supposed to be what? Symmetric about the what? About the mean mu. Meaning that the left side is just like the what? The right side. It's true. It's all true. You guys think I make it up, but it's not made up. We live in a cruel world. Okay? That looks a little better, right? All right, here we go. So let me ask you this question here. What percent of the bell is shaded? We're going to play this shaded bell game. What percent of the bell is shaded? What would you guys say? What percent of that bell is shaded? Huh? 100. Oh, good guess. Is that easy? I would say this is what? 100% is shaded. Next example. Oh, is this too easy? 50%. How do we know that's 50%? Right? Isn't that the left side there that's shaded, 50%? I'm sorry, the right side? What about this? See if you're really awake. What percent of the bell is shaded? Huh? Huh? Uh-oh. Maybe my bell's ugly. Is it 30%? It's not the whole thing. We know that, right? Well, let me be a little better then. How's that? It's not? Good. What percent of the bell is shaded? What is it? Good, 50%. Okay? So this is the left side. Now I want to point this out. This isn't negative. This isn't negative. What did I say in the past was the average height of men? What did we say? It wasn't 5'7", it was 5'8". Good. How many inches is that? 68 inches? Notice this. If the average height of men is 68 inches, 68 inches, right? Look at it this way. To the left, you don't have negative values to the left. Is that right? Because there's really no such thing as a negative height for a male, right? There's no such thing as a negative height for a female either. But the point is, there's no such thing as negative height. But what you know is that, yes, there are certainly a certain number of men who are what? Below the mean. Is that right? Below the mean of 68 inches. And in fact, there's 50% of the men are below the mean. 50% are above the mean. So this is not a negative area. This just simply means 50% are to the left of the mean. Or 50% of the bell is shaded. That's on the left side. That's all. And there are people who are to the left of the mean. Those are people who are below average. People to the right of the mean are what? Above average. So if your height is above 68 as a male, well, you're above average. If you're below, then you're below average. Okay, you guys okay with that? The average value is mu. That's it. Okay, we can even talk about the height of women. We could talk about the weight of men, but we'll never talk about the weight of what? Women. Why is that? Why do you think? Because it's we're all very sensitive about our weight. Is that right? I got to lose a few pounds. I got to lose a few pounds. All right. Anybody want to talk about their weight? Anybody want to talk about their weight? No? No? All right, let's see. Let's see if you guys are awake. What if I do this? What percent? Can you tell me what percent of the bell is shaded? What do you think? What percent of the bell is shaded? Huh? 35. Good. It's not a trick question, right? I'm labeling it what? 35. Not that bad, right? Is that easy? Too easy. Okay, here we go. Let's ask you this question then. See if you guys are awake, really. Guys, you're reading my mind. How did you know? Huh? 15%. What is it? 15%? Is that a trick question too? You guys want to know something? We're all going to be able to deduce the answers you know, looking at these pictures. You know that? But what starts to happen in the future is people will start going, oh, what is the answer to this? I don't know. It's interesting. How did you deduce that this was 15%? How do you know that, yes, that is 15%? How do you know that? Yeah. Oh, so you're telling me that this whole thing, you're saying, wait a minute, if this whole thing is what? 50. That goes forever, right? Because the tail, you're saying if that's 50, that you subtracted what? 35 and got 15? Is that true? How about if I do it this way? When some people look at this, they have a hard time seeing that it's 15. Some people do. Because there's a certain amount of, we all have certain I think it's called spatial intelligence, you know. How about if I do this? Call that X% because you don't know it. You okay with that? Would you guys agree if I said this to you? That if I take the 35 and I add it with what? This part plus this part, which is X, what should it equal? 50. You guys okay with that? This portion here plus this portion should be what? 50. Could you solve for X? Good, you took the prerequisite. Subtract 35 from both sides. In other words, X is what? 50 minus, see, Yowzi, this is what you did. This is really what you did. And what is that? 15%. Is that right? So, in other words, you're right. That missing tail is exactly what? 15%. Yes. And this is special. This is known as a, is that on the right side or the left side? This is known as a right tail. First of all, because it's a tail, it's thought of as a tail of the bell, and it's on the right side. And yes, if you want to ever figure that out, you do exactly what Yowzi said, and you do it forever. It's no different. If this was 40, what would the right tail be? If this region here is 40? 10. If it was 25? If it was 12? 38? 38? 50 minus 12 is 38. See what I'm saying? This is how you compute a right tail forever. You do it now, you do it later, you do it forever. Okay, what about this? See if you're really awake. This is going to be a left tail. This is now rocket science. We said this portion here is 40.3%. Could you tell me what percent of the bell is shaded? How did you figure that out? 50 minus 9.7% is what? What is that? Oh, sorry. 50 minus 40.3 is what? 9.7. Good. Is that easy? Okay, let's see if you're really awake. This stuff is just way too easy. What's it going to be, Adriana? Well, what's the question? What percent of the bell is shaded? What is it? What do you think? What would you do? The question is, what percent of the bell is shaded? This is 100%. What is this 35% referring to? What is it pointing to? The right side of the bell from mu to some value here. What are the 40.3 referring to? The left side of the bell, mu to some other value here. So what percent of the bell do you think would be shaded? What is it? 70 point, is it what? How did you find that answer? 40.3 plus 35 is 75.3%. Try not to. I would suggest this. Some people want to come up with some rules for when they add or when they subtract. They want a rule. When do I add? When do I subtract? They want to oversimplify this. Oversimplify. I say this to you. You deduce the answer. That will tell you whether you add or subtract. And then you go, well, what do you mean? Well, if this is 35%, the whole thing is 50, you do what Yowzi did. She deduced the answer. 50 minus the 35. You see what I'm saying? If it's a left tail, same thing. If it is what you see here, how do you find the total shaded area? Isn't it true if you add the left side plus the right side, you get the what? Total. Does anybody here keep money in their right pocket and their left pocket? No? Yeah, sometimes we do that, right? It's probably more likely to be a guy. Sometimes I got change in my left pocket and I got bills in my right pocket. You guys know what I'm saying? It just happens. Well, if somebody were to ask me this question, how much money do you have? Right? How much do you have? I got $40.30 in my left pocket. I got $35 in my right pocket. What am I going to answer? $75. Exactly. You see what I'm saying? How much you have on the right plus how much you have on the left, that's how much you have. It's just that simple. It's deduction. You see what I mean? Is that too simple or too easy? Then why do people miss it? All right, here we go. You ready? We have some more to look at. See if you're really awake. I mean, I think that a lot of this stuff is really simple. It's just a matter of you following up, going home and practicing. That's all it is. That's all it is. You may say, well, there's so much to do at home, right? You get on what? You rather do this, you rather do that. But when you're a student, what's the story? All you do is this stuff. You have the rest of your life to go to the beach. You can go to the beach for the rest of your life. But when you're a student, don't go to the beach. This is what you do. Okay, let's see if you're really awake. What percent of the bell is shaded? How did you guys know that? This is what? They didn't even tell you what that was, did they? They left that off. That was mean. That was mean. But what do they want you to recognize? That all of the left side is what? Shaded. All of the left accounts for how much? 50%. So if you have $50 in your left pocket and you got $35 in your right pocket, how much money do you have? How much? 50 plus 35 is what? 85%. You guys okay with this? 85% of the bell is shaded. Similarly, meaning that if they give you this sort of scenario in which they label this to be the 35%, here is mu, what percent of the bell is shaded now? Is it the same thing? How did you deduce that? This is how much? How did you know that was 50? I didn't write down 50. The right side is what? Shaded. $35 on your left pocket plus the 50 on your right. What is that? 85 what? Dollars. We should have just went to the beach today. It's just that easy. I could have did this in the sand, right? We could have all been by the water. I would have got a branch, drew that bell and asked you what was shaded, and you guys would have all the answers, right? Exactly. That's a challenge. So we got all these pictures. What about this? Let's make it really hard. You guys ready for a hard one? Okay. See if you're awake. What is it? Is it 28%? How did you figure that out? How did you do that? Huh? What is this? What, in other words, what do they really communicate? This portion is how much? 40. Is that true? And the amount that's not shaded is what? 12. Is that right? So how did you deduce the answer? You said this, assume that all of the 40, this is what people should be thinking of. This is what's happening. You assume that 40% is shaded. It really isn't. From here to here is 40. And then you throw away how much? The amount that's not shaded. How much is not shaded? So it's 40 minus the 12, which gives you what? What is it? 28%. You're right. Yes, it's 28%. Okay, you guys ready for the last one? If you get this right, and you had them all right, then you get your break. No, you can't go home. You guys all want it. What are you going to do at home? That's the problem, is you go home. You guys know? The problem is home. You get on the phone, you watch TV, you sleep, you play video games. What else do you do? You clean? Oh, that's good. See if you're awake on this one. This will say is 8%. And this will say is 38%. What percent of the bell is shaded? Huh? This whole thing is 38%, but 8% is not shaded. What does that mean? It's what? 38 minus 8 is what? 30%. Oh, you guys, this is too easy. 30%, 28%. I'm trying to think, is there anything else that we may need? Nope, it looks like we're what? We're good. Is this easy? Is that easy? Okay. Let's have a break here. Let's see what time it is. Is it on? Okay. Here we go. We'll put the rest over here in case people come in and they need this. Put them right here. No, it's different. Yeah, we're going to talk about it. Okay, you guys, let me just say this. The table that I'm going to give you is different than the table that's in your book. The table that's in your book is a new table that Trilla came out with, I guess. I'll explain why I use what I use here. I use the older table. But I want to point something out. Here's the reason why I use what I use. Do you guys know what the key to each one of these problems was? You guys know what the key is? You see this? You see this? You see this? 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 This and this? And then this and this. What I have circled is the key to answering every one of these questions. Okay? That is, here is the key. And my red marker is gone. Let's try to see if we can keep this key in red. I hope we can. Okay, so I circled in red the key to answering each one of these questions. Okay, here we go. That I'll call the key percent. Okay? If we know this, then we can answer all the questions. And you may say, well, what are you talking about? Well, guess what? You see in this problem, I circled the key. Well, this is what? If we knew that this was 35%, then we answer the question. You may say, well, okay, why did you circle the key here? Well, guess what? If I know what this is in red, 35%, they're asking me what percent of the bell is shaded, this blue, the 50 minus the what? 35. So if I knew this, I can answer this right tail question. Is that right? If I knew that this is 40.3, this, I can answer the what? The left tail question. If I knew what this is, and then you go say, well, it's 35. But then you go, oh, but that's not the key. Why? Can anybody tell me why is this the key also? Meaning, if I know what this is, and you may say it's not the right side because you have your key here being the right side. Well, let's note this property. Because of symmetry, this is the same as potentially what you have on the left here. Because of symmetry. So meaning that if I knew this and this, I can answer the question. If I know that this was 35%, I can answer the question. 50 plus 35 is 85. If I knew that this is 35, 35 plus 50 is 85 because of symmetry again. That symmetry property. If I know that that this whole thing is 40, and this whole thing is 12, so in other words, I'm knowing a combination of the 40, a combination of the 12, I'm able to answer and deduce the question. Same thing because of symmetry. If I know this whole thing is 38, and this portion is 8, I could deduce that this is actually 30%. Now, what's happening here? If it's to the left of mu, we're using the property of symmetry. If it's to the left of mu. If it's to the right of mu, we're using this. Okay? Now, I'm saying this is the key here. I haven't put it all together for you yet. But I'm going to go through another exercise. And this time the exercise looks like this. I'm going to show you how to determine the shaded area. Okay, it's actually determined the percent of the bow that's shaded, but I'm going to show you how to determine what I wrote here in red. How do you find those values? I'm going to show you how to do that. Okay, so if I show you how to find that, percent of the bow that's shaded in red, which is the key, then you're going to be able to answer all those questions. You see what I'm saying? How did I come up with this 35? How did I come up with this 35? 40.3. 40.3 and 35. How do I come up with that? I'm going to show you now how to do that, okay? And this is where the table comes in. So here we go. The picture looks like this. I'm first going to show you a special situation known as the standard normal distribution. The standard normal is still a normal distribution. It's just also known as the standard, okay? The center mu here has the value 0 for the standard normal. Mu is 0, and for the standard normal, the standard deviation is 1. We'll talk about that later. The standard normal is represented by the letter Z. Z represents the standard normal distribution. So what you'll see here on that handout I gave you is Z. What you don't see, they'll put the Z value here. What you don't see, though, is that this is shaded from 0 to that Z value is shaded because it just didn't come out. So if you look closely, you might see it's a little what? Shaded. Do you guys want to come up and get your handouts? Okay, so look closely. You're going to get fired. They're going to tell you, go back. All right, here we go. You see the Z table, right? Your Z table, doesn't it kind of look like this? Right, where you have all these values? You got these rows, and it looks like this 0.0, 0.0, 0.1, 0.2, all the way to 0.9, and then you have 1.0, all the way to 1.9, and then you have others, though, continues. And then it's 0.00, 0.01, 0.02. Notice that on top, the column has values in the nearest hundredth position. These has values in the nearest tenth position. Okay? And so here's what's happening. In each one of these settings that I wrote in red, and I said, okay, this is the key. In order to compute or determine that value of 35, there was a corresponding Z value that was playing a role here in that determination of that value. There was a corresponding Z value. Z value. Z values too. Z value. Z value. There was a Z value that was playing a vital role here that I didn't even mention to you until now. We said this is the key. Z value. Z value. Okay? If it's a standard normal, mu is 0. Mu is 0. And so what I'm showing you here is how to use that Z value that's under the hood that we didn't even discuss to get that percent of the bell that's shaded, the red percent of the bell. Okay? So what you have here is that important Z value that we're now going to discuss that was really playing that role. Now, for example, if I want to determine the percent of the bell that's shaded for this setting here, from 0 to some Z value of 1.21. This is my Z value. Here's what I do, the value of Z. I get as close as I can to 1.21 without going over. What value here as a row is close to 1.21 without going over? In other words, what are you guys going to say? What's closest to 1.21 without going over? 1 point what? Okay, good. It's 1.2. Does everybody agree with that? So I'm going to look for the 1.2 row. That first value is my row. What do I look for? The row that is closest to 1.21 without going over. 1.2. So you see how this is only values for Z that are to the nearest tenth position? Okay? So you're going to have to look for the 1.2 row. Now you fine tune with the columns. These are your columns. All of these are columns. Which column do I add to the 1.2 row to get the value of 1.21? Which column will do the trick? Will it be the 0.00 column? Will it be the 0.02 column? Will it be the 0.09 column? Which column? 0.01. Good. So really what's happening is you're taking a row and you're taking a column. It's the 1.2 row, the 0.01 column. If I add those values, isn't it 1.21? So here's what I do. If you can determine the value that is in the 1.2 row, the 0.01 column, you are answering what percent of the bell is shaded from 0 to 1.21. And what do you guys see there? What is it? Is it 0.3869? So what you guys notice is this here is 0.3869. This is the probability value, but as a percent of the bell that's shaded, it is 38.69%. So what you guys see here is the percent of the bell that's shaded for the corresponding values of z. You guys see what I'm saying? So that is how we determine the percent of the bell that's shaded from 0 to some positive z value. Now here's the deal. Let's note this. Let's note, this is vital here that we actually recall this. Let's note for negative z values. So if you have a picture that looks like this, and I have to determine, and you go, oh, here's a negative z value, negative 1.21. I have to determine the percent of the bell that's shaded here for between 0 and a negative 1.21. You're going to sit there and you're going to tell me, I don't have a z table that has negative z values. The table you gave me only has what? Positive z values. You're going to go, oh my God, you're trying to confuse me. I'm going to tell you what. Use the table for the positive z values. Why am I going to say to use the table for the positive z values? What's the key word here, or the key phrase? Why do I use the positives and not, why don't I have a negative table? Why is it the same thing? Why is this the same? Why is it the same answer? 38 point what? 69%. Why is that the same? It's the same for one key word or key phrase. Because of? Yes. Remember I erased it here for you? Because of symmetry, what you see on the right here is the same as what you see on the what? Left. So even though values of z here can be negative, like a negative 1.21, even though they can be negative, okay, that percent of the bell that's shaded is still positive. And it's all because of this key word, because of symmetry. You guys have any questions on that? So when I say I gave you only one table because I wanted to make it easier, instead of giving you two tables, because what would happen if I just gave you two tables, it'll have everything's the same, but these values are now negative. All this will still be the same. So give you one table, and you should be okay. So if you ever have to find the percent of the bell that's shaded for this kind of picture, between 0 and what you have over here, use the same table, the positive table, because symmetry allows you to do so. Okay, you guys okay with this? Now I'm going to do this to you. I'm going to ask you a few questions here. Because we have to go through all this before we go through a single problem. So here we go. For example, zero, 2.4. What percent of the bell is shaded if my z-score is between 0 and 2.4? What do you guys look for here? What do you look for now? Which row do you guys try to find? Get as close as you can to what? The z-value. You have to have some row plus some column. Notice the rows again. The rows only go to values to the nearest tenth. So get as close as you can without going over to 2.4. You sit there and you go, oh, which row? 2.4 row. Okay, 2.4. But you say, I thought I had to get as close as I can without going over. Well, if it's exact, then go with that exact value, 2.4. Now, why do you think over here there is a 0, 0 column or a 0, 0, 0, 0.000 column? For when the case that you get the exact value. So that here, if I take the 2.4 row, because this gives me z-scores to the nearest 10th position, here I fine-tune to the nearest hundredths, I will take the 0.00 column, because isn't it true if I take 2.4 and add it with 0.00, I get 2.4, the z-value? So yes, in this setting, you are going to take the 0.00 column. And what do you guys see there? What score is there? Point what? 0.4918. This is the probability value. As a percent of the bell that's shaded, that's 49.18%. You guys see what I'm saying? So you're using those values down there to determine the percent of the bell that's shaded only for these pictures. Note, what about the negative version? What if it was this? Negative 2.4. What's the answer now? What's the answer now? What is it? It's still the same. 49.18%. Why is it 49.18%? Because of what? Symmetry. Good. Anybody have any questions? You sure? Okay, I'm going to ask you a few questions then. We're going to test to see, we're going to test your knowledge. Test to see if you can answer these questions. Let's say this is 1.68. Okay, and this is negative 0.12. Let's do it in red to be consistent. And tell me what percent of the bell is shaded now. So what did you guys get? Which row are you guys looking for here? Yeah, which row do you guys look for? You're going to look for the 1.6 row, is that right? The 1.6 row, because this is your z-score to the nearest 10th position. Get as close as you can without going over. Isn't that 1.6? Okay, what column do you look for now? 0.08, you fine tune so that z, row plus column, 1.6, 0.08, isn't that 1.68? What score do you see, or what percent of the bell is shaded there? What do you see? 0.4? 535? That's the probability. As a percent, isn't it what? 45 point what? 35%? Now, what about the second one? What does it say? What about this one down here? What are you looking for here? Oh, it's negative. Uh-oh. Can somebody find a negative table? Why? Why do we only use one table? Because of symmetry, yes. So, what are you looking for? Get as close as you can to 0.112 without going over. What is it? Point what? 0.1. That's a 0.1 row. Which column do you look for now? 0.02 column. Because this is a z-score here, but it's the z-score to the nearest 10th position. All of these are in tenths values. And then you fine-tune to the 100th position. What do you guys see there? Point what? 0.47? Oh, 0.047. 0.0478, you said? Okay. Notice this is a probability, but as a percent, what will this be? 4.78 what? Percent. Is that right? It's 4.78%. All right, anybody have any questions? Question? No? You guys sure about this? No questions on it? Yeah. How did I get the 8? Okay. What's the z value? See this? It's 1.68. Is that right? It's 1.68. So I'm going to get as close as I can. First, I have to select the right row. I have to select the right row. I get as close as I can to 1.68 as a row value without going over. So what is that value? 1.6. Because all these are to the nearest 10th, right? I get the 1.6 row. I have to add it. If I add a number to 1.6, what number do I add to 1.6 in order to get 1.68? Well, then that'll be 1.8. Remember, how do you add decimals? 1.6, 0.08. Remember that? How do you add them? It's not going to be 0.8. It'll be 0.08 because of the nature of adding decimals. 8, 6, keep the decimal, 1. You see that there? So it's going to be the 0.08 column. So in some sense, we're fine-tuning. 1.6 row, 0.08 column. That, when added together, is 1.68. This is a system that they created to determine the percent of the bell that's shaded. So now, that's how we see what's in the 1.6 row, 0.08 column, and we get 0.4535. What that means is this is the percent of the bell that's shaded from 0 to 1.68. Anyone else? Any other questions? You sure? Is that easy? Okay, you sure? Okay, here we go. We're still going to play the game. What percent of the bell is what? Shaded, okay? Here we go. Example. We're just going to see if you guys are awake. We're going to put all of the ideas together that we talked about earlier. All of these ideas are coming together. Okay, you guys ready? We're putting together the game we played earlier and what we just learned about how to read this table. Okay, we're going to put those two ideas together, meaning, can you guys actually answer this question? What do you need to know again? Remember I started this discussion by saying this thing called the key, where this was the key to every problem. Knowing this percent was the key to each one of these problems. Didn't we say that? If you know how to determine the key, then you could determine all the answers. Right? Didn't we say this? Okay. Who can tell me what percent of the bell is shaded on the left here? Good. That's 50. Is that right? What percent of the bell is shaded on the right here? What is it? How do you know that? We did it already. That was the key. 49.18%. Isn't this the key? And that's 49.18%. So, what did we say this morning? How much is in your left pocket? How much is in the left pocket? $50. How much is in the right pocket? $49.18. How much do you have? $99 and what? 18%. You guys okay with that? $99.18. Question. Okay. Isn't this interesting? Remember I said earlier, you guys can do all these problems. You go, oh, that's easy, it's easy, it's easy. But then all of a sudden, you start to even question yourself. The key is to know what percent of the bell is shaded from 0 to some positive z-value here. Is that true? Now, why is that the key here? Because the left is 50. You already know that. You don't have to use a table for that. From 0 to some value, isn't that 50% of the bell shaded? Half of this thing is shaded. That's why it's 50. All you need to know is what percent of the bell is shaded from 0 to 2.4. From 0 to 2.4, that's all you need to know. You know it's 49.18% because we already what? We did that right here. We did it. $50 is in your left pocket. $49.18 is in the right pocket. What's 50 plus 49.18? 99.18. Isn't that right? USD? Isn't that right? USD. Oh, I keep USD. USD. Darn it. I got to remember like yo. Like, right? Yo. Isn't that right? 50 plus 49.18? Now go to the next one. Huh. What percent of the bell shaded here? Let's see. Oh, how much is in your right pocket? The 50%? How much is in the left pocket? Oh my gosh. That's a negative 2.4. Huh. No, because of what? Symmetry. This is also what? 49.18%. So here's the idea. If in your left pocket you have $49.18, in the right pocket is 50, how much money do you have together? 90. How did you find that value? You added them. That's no different than what we talked about earlier. Go home, rewind the tape, and look at it. $99.18. What about the next one? What are you guys going to say here? Can you tell me how much was in your right pocket? How much is in the right pocket? From 0 to 1.68? Did you guys notice? Did we do that? Isn't that the key again? The key? How much is in the right? $45.35. Now, what about the left? From 0 to a negative 0.12. Well, because of symmetry, we look at 0 to a positive 0.12. Didn't we do that one already too? How much is there? $4.78. So this is $4.78. How in the world do I deduce the final answer? What percent of the bell is shaded? You add them. $4.78 is in my left pocket. $45.35 is in the right pocket. How much? What percent of the bell is shaded? 50.13%. 50.13% of the bell is shaded. How much is on the left plus how much is on the right? This is what you found before. Just because they're decimal values, don't let it throw you. Don't let it throw you because they have decimal values. It's okay. Add how much is on the left plus how much is on the right. It's 50.13. You say, I thought it can't be more than 50. Well, of course it could. You got some on the left, some on the right. Okay. Oh, this is the hard one, remember? Oh, this is the hard one. It's not that bad. Why is it not that bad? Do you remember the format we did earlier? Did you guys take your notes? What was the key? If you knew how much is not shaded, how much is not shaded there? How much is not shaded? 0.12. How much is not shaded here? Isn't that what? 4.78%? Right? 0.12? 0.12? Isn't that not shaded? Now, how much would be shaded if we went from here to where? To over here. How much is from 0 to 1.68? How much would be there from 0 to 1.68? Didn't we do that here? Yeah, it's what? 45.35. That's 45.35. Okay? So the only thing that you guys had new to this process was you are now determining this value and this value based on the z values here, based on these two values. How do you determine that? You use your z table. So how did we deduce the answer earlier? 45.35 minus 4.78. What did that give you? What is that? Is that 39? No, that's what? 41? 40? 40.57% of the bell is shaded. 40, this is 40.57%. That's what's new for you, is you're determining that percent of the bell that's shaded using the z table. What about this ugly one here? Do you remember we did that process too? Earlier? Let's see if you're awake. What percent of the bell is shaded from in this whole region here, the key? From 0 to a negative 1.68. What is it? 45.35. That was the key. We did this already. It's a 0 to 1.68, 45.35. Now, what percent is not shaded? Do we know that? Negative 1.21. Do we know this? We know the positive, 0 to 1, positive 1.21. It's 38.69. We know the positive using this table. We did it already. But because of symmetry, this also is what? 38 point what? Isn't that also 38.69%? Because of symmetry? So then, how did you get your answer earlier? 45.35 minus 38.69. It's 6 point what? Oh, 6 point? Oh my God. 6.66%. Let's be careful. 6.66. It's by coincidence. 6.66%. Okay. Now, let's do this last one here, or these last two. Oh, this is what kind of tail? That's a right tail. Is that right? Okay. So I got 0 to a positive 1.68. Do I know how much is not shaded there? Remember, isn't this the key? Right? We talked about this being the key. How much is not shaded? 45 point what? 35. How did we know this? We already did it. It's over here. We already did those. So who remembers the right tail process? Yosdi. You're the one who told us. What is it? From what? Huh? What do we subtract? What do we subtract it from? Good. 50 minus 45.35%. And what do we get as an answer? 4.65% is in my what? In my right tail. The last one. Here we go, the last one. Isn't this a left tail? What's the left tail procedure? The left tail procedure is take the 50%, all the left side, all of this, and throw away what percent is not shaded. How do we find the percent that's not shaded? Remember the key? If I know this, the percent that's not shaded, I can deduce my answer. Do I know this? Yes, I do. What is it? But that's positive. How can I get away with using this? Symmetry, good. 38.69%. So this here is 38.69%. If I subtract that from 50, I get how much is in my what? Left tail. So what is that? Good. 11.31%. That's how much is in the what? The left tail. I'm just curious. Would you guys rather be selecting marbles or cards from a standard deck? See, this is probably, I don't know. Some of you may say yes. Some of you may say no. The point is that this is a very different process. And, so there's benefit and there's drawbacks. The benefit is it's not like what it used to be, but the irony is that's the same drawback. It's not what it used to be. Okay, you guys okay with this? Well, guess what? You guys have graduated to the applications. I'm now going to give you a format or a procedure in order to do these problems, these normal distribution problems. Okay, you guys ready? Let's give you an example. Here's an example. I don't know, what should we do? What application should we do? Depends what you guys care about. What do you guys care about? Huh? Family? What about family? Huh? All right, how about if we do this? We've got to be careful. Family. That one, we could be creative, but family. Family and the normal distribution. What should we do? Huh? Huh? What's that? What's that? I'm sorry. Shoes. You care about shoes? Money. What do you mean? Huh? The income of a family of 4 is normally distributed. With a mean of, what's the mean? What do you think, Eddie? What's the mean? Huh? Let's say, anybody have an idea? What do you guys want to say? We just did our taxes, right? What's the mean income? Family of 4. Since we care about money, we care about family, we'll put it together. What's the mean income? I'm not saying that income is normally distributed, but we're going to say it is. Is that 2 L's for normally? Or 1 L? We're the English majors. There we go. Well, you can make some assumptions. They maybe don't all work. Maybe you're mom, dad, and two what? Two kids, right?
So basically 2 working parents.
Could be 2 working parents, 1 working parent. Doesn't matter because this is has a mean. Is that right? So they're taking the incomes for family of 4s. In some cases, yeah, it may be both parents. In some cases, it may be what? 1 parent. Does it have to be the father? No. It could be the who? The mother. So you just don't know, right? Huh?
I said I know the income of my 2 parents that add those income. So
Well, why don't we say what is it? What should it be? What should we say? It's up to you. 80,000? Okay, we'll say $80,000. Is that right, Eddie? Good. With a standard deviation with a standard deviation of what? Remember, what does standard deviation measure? The consistency, right? This is a mean value. So let's say the standard deviation of how much? How much? Oh, let's say 18,000, okay? We're making up a problem because this is what you guys are interested in, money and family.
standard deviation again?
What's the standard deviation?
Yeah. How did you?
How do we compute it? In real life, what you would do for all of these things is note, to compute the mean, that's the sum of all the data values divided by the total number of data. And again, to compute the standard deviation, the sigma, we can use the definition. The sum of those data scores minus the mean, okay, squared divided by what? N minus 1, and that's the square root. Remember that formula? And then we had a shortcut formula. So in real life, you got a list of data. You can compute the mean this way, compute the standard deviation this way. And this, remember, represented how consistent the scores were. Okay? So here is the question. Here's going to be your first question. What percent of families of 4, because this only applies to what? A family of 4. What percent of families of 4 make at least what? $100,000 per year. And this is per year information. That's your question. Okay? So here's a procedure. This is going to be your procedure. Here's a procedure. I would say this to you, to follow this procedure religiously. What does that mean? Anybody go to church? What does it mean to follow something religiously? You're really trying to say do this all the time. But I don't know, what does that have to do with being religious, Ed? Are you supposed to go to church all the time? Huh? Okay, so follow this procedure. Draw a picture of the question. Draw a picture of the question. The questions are usually given in terms of what's known as a normal distribution. So X is a normal distribution. Draw a picture. The second part is to do this after you draw a picture. You're going to convert the normal distribution to a standard normal distribution via the conversion formula. Z equals x minus mu over sigma. You guys should recognize this formula. Do you guys recognize it? You did it in the past. Step 3, use the Z table to deduce your answer. You do this and you will answer these questions. Okay, you guys ready? Notice again this. You see the question? They said that the income is normally distributed. That's your x. X is a normal distribution. Notice this. Can you tell me, for this distribution, what is the mean? 80,000. What's the standard deviation? 18. So that this is your mu value, and this is your what? Sigma value. That's the mean and the what? The standard deviation. Do you guys agree with this? So what's going to happen in every question is that they are going to give you, bless you, a phenomena that is normally distributed. That's your x. They'll give you the mean, and they'll give you the what? Standard deviation. Let's go through the process. The process is this. Draw a picture of the question. The question is a normal distribution problem. You're going to draw a bell for the question. It's normal distribution. Okay? We're going to convert the normal distribution, this normal bell, to what's known as a standard normal distribution. And how do you convert it? Via this Z value formula. This is also known as the standard formula. The standardization formula, or Z is known as the standard value. And then we're going to use that Z table. So here we go. What does the question look like? Can you guys tell me what's in the center of your normal distribution? Isn't it the mean? Yes. Okay, what's the mean in this problem? $80,000. Okay? $80,000 is in the center. What did they ask? What percent of the what percent of families make what? At least what? $100,000. You guys see what I'm saying? Is that what they asked? What does the at least mean?
Greater than or equal to.
Well, first let me point this out. You see 80,000? It's in the center. This is the mean. Okay? That's our mean. Isn't 100,000 to the right of 80,000 because it's larger? So it's to the right. So values that are at least 100,000 are where in relation to the 100,000? To the right or to the left? So they're asking you what percent of the bell is shaded as a right tail. This value of 100,000 separates people who make at least 100,000 to the right versus people that make what? Less than 100,000, they are to the left. Okay? You guys see that there? They're asking this question. This is a picture. This is step one. This is that first step. The second step, okay? The second step is to do what? What does it say in step 2? Anybody want to tell me? What does step 2 say? Convert using what? C is x minus mu over the standard deviation. Can you tell me what is the mean? 80,000. What's the standard deviation? 18,000. So in other words, your conversion formula really is z is x minus 80,000 divided by that 18,000. So if you tell me what x is, I can convert it to a z value. Do you guys want to know what x is? X is what? What does it say? X is a normal distribution. So they're saying, what percent of the families make at least 100,000? That's your x value. The income is 100,000. So this is x. So if I plug in $100,000, I'm converting that 100,000 to a z-score. Z is 100,000 minus 80,000 divided by what? 18,000. So Z is going to be 20,000 divided by 18,000, right? And what is the value of Z then? Approximate this Z score to the nearest 10th position. I'm sorry, 100th position. 1.11. So here's what I want to point out to you. That Z is a standard normal distribution. Is that true? That's a standard normal distribution. Do you guys know for the standard normal distribution, what is the center of that distribution? What is the mean for the standard normal again? That was what? Wasn't that 0? Now, what is 100,000 as a standard normal value, as a z value? What is that 100,000? That's what? 1.11. So when I say that you just converted this normal distribution to a standard normal, what it means is that, I'm going to erase this in green, 80,000 really is 0. 100,000 really is 1.11. Meaning that that conversion looks like this. 0, 1.11. And so if, as a z-score, a standard normal distribution, so if you compute what percent of the bell is in your right tail here, that is answering the question. That's equivalent to saying what percent of the bell is in this right tail over here. And this is the process. So step 3, this is your step 2. Step 3 says what? What's step 3? Use what? The z-table to deduce your answer, meaning refer to what you guys have been paying attention to all day today. What was the key again? If you knew what percent of the bell is here, you use the right tail format. What is the right tail format again? You guys remember? I don't know what this is. I'm determining this. This is my answer. Is that right? This is my right tail. So, how do I do this? You guys want to tell me? 50 minus what? What do I look for? Get as close as you can to 1.11 without going over. What is it? 1.1. Fine tune. 0.01. What do you guys see here? 0.36. Does anybody second that? What does that mean? That the key area, this key area is 36.65%. Why is this the key to the problem? Because 50% minus 36.65% is what's in your right tail. What's in your right tail? What is it? 13.35%. So 13.35%, okay? 13.35% is in your right tail. Do you guys want to know what this means? This means that the IRS has determined that 13.35% of families of 4 have an income of at least what? $100,000. What's our time like? Nice. Anybody have any questions on the procedure? Sure? All right, well, I'm going to ask you more questions then. What percent of families of 4, this is a 4, make 1 less than 90,000 per year? 2, at least 55,000 per year. 3, between 55,000 and 90,000. 4, between 90,000 and 100,000. 5, at least 55, less than 90, between 55 and 90, between 90 and 100. How about we'll say less than 55? Okay, and I hate to say this, but if you've done one of these questions, you've done them all, but you got to practice a few of them. Okay, you got to practice some of these. I've cut straight to the chase. I cut straight to the applications of this. What you do in each case is follow the what? Procedure. You guys know that when you go to the doctor and you have some sort of surgery, do you know that there's some sort of procedure that that doctor follows? And what does the doctor usually tell you? Don't worry, I've done this procedure, what? 1,000 times. So what do you guys have to do with this procedure? Practice it what? 1,000 times. And then you could operate. Yeah. Say that again? Yes. It's still families of 4. It's still the same setting, meaning that the mean still is 80, standard deviation is 18,000. Draw a picture of the question. I just want to show, just to make sure. I just want to say this. You see, what if the question were, what percent of families made less than 100,000? Less than 100,000. What is the value of 100,000? What does that mean? What values are less than 100,000? Values that live where? To the right of 100,000 or values that live to the left? So you shade everything to the left. That's if it's less than. Okay, so try these out, and we'll see what you get. I mean, of course, we'll go over them. Okay, Eddie, let's pause.
I was
Just to see if you're on the right track. Okay, we'll try this one here. The less than 90, here's the process. Draw a picture of the question, step 1. What's in the center? Anyone want to tell me what's in the center? 80,000. Okay. Now, what's the question? Less than 90,000. So, where is 90,000 in relation to the 80,000? To the right or to the left of 80,000? So, is this where 90,000 would be? Is that right? Okay. Can you tell me what values are less than 90,000? Values to the left of 90,000 or values to the right? Values less than live where? To the left. So shade all of the curve, the bell, that's to the what? To the left. You guys okay with that? Now that is step 1. Less than 90,000 is everything to the left of 90,000. What do you do now? What's the next step? Convert. Z equals x minus, what is mu? Okay, mu over sigma. Tell me, what is mu? What is mu? Isn't mu the mean, which is? The 80,000. This is 80,000. What's the standard deviation? 18. So your conversion formula really is z is x minus the 80,000 divided by 18,000. Okay? What value are you converting? Not 80, because you already know that that's always what? 0. If I plug in 80,000 here, 80,000 minus 80,000 is 0. 0 divided by 18,000 is 0. So this z value is 0. You don't have to convert the middle ever, because you know for the standard normal, it is always 0 as a mean. That's 0. So that one's going to be free of charge all the time. What you really want to convert is what? So the 90,000 minus 80,000 divided by 18, you're right, is going to be what? 10,000. 10,000 divided by 18,000, what's that going to be? 0. What? 56. Round this to the nearest tenths. So then this is really 0.56. So that the picture that you have now, the z-value picture, is 0 to 0.56 as a z-value, and everything to the left is shaded because 90,000 is 0.56 as a z-value. Remember you converted x values before when you did gradient on a curve? We're converting 90,000 to a z-value. Here it's 0.56. Okay? So this is actually step 2. We drew the picture of the normal distribution, the x distribution. Now we're drawing a picture of the corresponding z distribution. Every x distribution can be written as a standard normal distribution, in which we use that same table. So this is the second step. You guys okay with this? What's the third step? Use the z table to deduce your answer. What's in your left pocket? 50%. What's in the right pocket? How do you find what's in the right pocket? You remember that? Look for z-value. Okay. Get as close as you can to 0.56 without going over. 0.5. Fine tune with the column. 0.06. What numbers in the 0.5 row in the 0.06 column? What is it? 0.2123. As a percent. Excuse me. 21.23 what? Percent. What is 50 plus 21.23? What is it? 71.23%. You guys okay with that? Ladies and gentlemen, 71.23% of families of 4 make less than $90,000 per year. Try this next one, at least 55,000. Question 2. The at least 55,000, so you guys can see the process again. At least 55. How much do they make again? 80,000 is the mean. Now, where does 55,000 live in relation to 80,000? To the left. Here's where 55,000 is. Is that right? You guys okay with that? Now, if you make at least 55,000, what values are at least 55,000? Values to the right of 55,000 or values to the left? I'm sorry. Yeah. Which one? Where are you looking at? This one? In what sense? Well, to the left, isn't that 50? And to the right, from 0 to 0.56, is that 21.23? Is that what it is? Okay. So then what percent of the ballot is shaded? The 50 plus the 21.23, which is 71.23. Okay? Left pocket, right pocket. And again, now this one, the question is, what percent of the bell is at least from the 55,000 here, right? What percent of the population make at least 55,000? What numbers are at least 55,000? Numbers to the left of the 55,000 or numbers to the right? Numbers to the? Uh-oh. Okay, good. Numbers to the right are what? 55,000. Because at least 55,000 is 55,000 or more. 55,000 or more. Isn't that right? If you make at least 55,000, you make $55,000 or more. Okay, you guys okay with this? What's the next step? Convert. Z is x minus 80,000 divided by what number? 18,000. Isn't that mu? Isn't that sigma? Those values are given to you. Those are always given. But tell me now, what is 80? If we take all these x values and we convert them to z values, to normal values, can you guys tell me, what does 80,000 get converted to? 0. If I plug in 80,000 here, isn't 80,000 minus 80,000 0? This will always happen when you convert the mean, always. What if I convert 55,000? I plug in 55,000 now. What's the corresponding z value? Z is, what's 55,000 minus 80? Negative 25,000. Divided by what? Divided by 18,000. What's the z value? Negative 1.39? Okay. Negative 1.39. So that your picture now looks like, as a z standard normal distribution, this is going to be 55, I'm sorry, negative what? This is negative 1.39, 0. It's a z distribution. Okay? Notice again, who can tell me what percent of the bell is shaded on the right in your right pocket? 50%. Good. What percent is shaded here? We're saying it's what? 41.77%. How do you find that? You look at your z table. You get as close as you can to, oh, that's a negative value. We don't have a negative value table. What do you use? Positive. Good. What do you look for? Get as close as you can to 1.39 without going over 1 point what? 1.3 row. Which column? The 0.09 column. What do you guys see there? 0.4177. That's what you guys should see, right? Final answer. Final answer. What's this? 41.77 plus 50 is 91.77%. So the IRS says, or looks at this and says, guess what? 91.77% of families of 4 make at least $55,000 a year. I don't know. We just made it up, right? And I don't know how accurate this information is, right? We just made it up. It's because you guys like money and you like family. Bless you. Do you need money to have a family? You do? Even if you're a mech. Yeah, you need some pigs because they got to eat, I guess. Do you got to eat? What does question 3 say? Between what? Between $55,000 and how much? $90,000. Between $55,000 and $90,000. So don't we know, again, that $80,000 is the mean and it's in the center? So can you guys tell me, where is $55,000 in relation to 80? To the right or to the left? To the left. So this is going to be your what? 55,000, right? Now where's 90,000? To the right. So here's where 90,000. So now what are the values that live between these? Everything what? In the middle. Isn't that between? Not between? So then you're going to shade what? The bell that's between these regions. All right, you guys okay with that? Anybody have any questions on this part? I just drew a picture of the question. What's the next step? Convert. What do you convert using? X minus the mean, 80,000, divided by the standard deviation, 18,000. That's your conversion formula. Now notice this is what's happening. I am converting not just one value, I am converting now what? 2 values. I already know 80,000 is going to be what? 0. I already know, what is 90,000 going to be? We already converted it. We did it already. Point what? 0.56. Did we convert 55,000 yet? What is it? Negative 1.39. So if I wanted, I can either use a picture on the top, or I can create another bell where this is 0.56 and this is a minus 1.39. Here's my z, shade everything this way. Step 3 says to use my what now? Use your z table to deduce your answer. Guess what? Do you guys want to tell me what this is? Do you want to tell me how much is in your left pocket? 41. How did you know that? We already did it. Good. Isn't it right here? Got it right here, right? How much is in your right pocket? How much? How did you know it's 21.23? We already what? We already did it. What do you do with these two answers? Do you subtract them? How do you know you add them? Left pocket, right pocket, you're right. What do you get when you add these values? It's like 60 something, right? 62, 63? What is it? 63 point? 63 point what? Is it just 63% exactly? Huh. Yes, another coincidence. 63%. Wow. Isn't that weird? That's weird. It was a nice whole number. You guys are telling me it's a nice, is it? Oh, okay. It is 63%, it looks like. Wow. Huh. That's weird. Question 4. What's that? Between 90 and what? 100. Between 90 and 100. Huh. Can I erase the procedure because you guys already have it? Between 90,000 and how much? 100,000. Okay, draw a picture of the question. What's in the center again? Why is that in the center? It's the mean. Good. Now, where does 90,000 live? Okay, where does 100,000 live? To the right of even 90. Is that right? What do I shade? Everything what? Between these, which means they're asking for what percent of the bell is shaded here in that picture. Okay, you guys okay with this? All right, you guys remember the format here? You got to convert now, is that right? And I'm going to be very, what? 0.56. What is 100,000? Guys tell me what 100,000 is? 1.11. We did all these already. Didn't we do it? We did these. So, who can remember the procedure? What do you do here again? Remember? What do you do? How much is here? How much is not shaded there? Huh? How much is not shaded? Do you guys know? How much isn't shaded there? 21.23%. How did you know that? We already did it. Where is it at? Where is it? Now, how much is here between these two? Right? How much is here? Between 0 and 1.11. What does it say way over there? I can't. I'm so blind. What is it? 36 point? 36.65. So what do we do with this information? Subtract 36.65 minus 21.23. What do you guys get? What do you get? $15.42%. 15.42%. 15.42% of the bow is shaded between 90,000 and 100,000, which means that 15% of the population, or a family of 4, makes between 90 and 100,000. 15.42%. What is the last answer? Less than 55,000. Anyone know? What's less than 55,000? What's that answer? Yeah, you guys go back here. Isn't this a less than 55,000 right here? Is that less than 55,000? And we know here that 91.77% make at least 55,000. So if this is 91.77, how much is this, or how much is this? How do you find that? What would you guys say? How would you get that answer? If I told you that, guess what, ladies and gentlemen? 91.77% of the population makes at least $55,000. What does that imply here? That what makes less than 55? Isn't that 100 minus the 91.77? All of the bell minus 91? And what does that give you? 9 point what? 9 point, what is it? 8.23. 8.23% make less than 55,000. Let's give you a note. If I select a family of 4 at random, what's the probability? The family makes. 1. Less than 90,000. 2. At least 55,000. 3. Between 55 and 90. 4. Between 90 and what? 100. Can you guys answer those questions? Let's not ask you what percent now. Let's ask you what probability now. And what are you guys going to get? What do you think the answer is? Percent. So how do you get probability? Anybody know? I'll give you the first answer. 0.7123. What's the second answer? 0.9177. What's the third answer? 0.63. And what's the third answer? 0.1542. What's the difference between answering a probability question and a percent question? Well, they're both, here we both have decimals, right? They're all decimals, but what's the difference? The difference lies in how you move the decimal, is that right? All of these values you see here were probabilities. You move the decimal and it gave you a what? Percent. So just move it back. Move it back and you're answering probability questions now. You've done one, you've done what? You've done them all. You just have to now do them in practice. That's what you guys are going to do, is that right? All right, Eddie. Let's give you some homework.